In 6.5, I've tried to lay out what the definition of a p-value is. The most important thing from this definition, both the probability-based one and the sentence up above, is our p-value is a probability of observing something as or more extreme than what we got, given that the null hypothesis is true. Like I've been emphasizing throughout all of our hypothesis testing, everything is made under this initial assumption that we are in chance world, or that there is 40% of students who are binge drinkers, or that the babies are just choosing at random, whatever the heck that might be. We need that initial assumption so that we can use our approximate normal distribution to get a test statistic and a p-value. This is not the probability that our null hypothesis is true, right? That's not what we're looking at. It's probability we would have gotten something like we got if it's true. Now, we usually use the idea that if something really unusual happened, there are one of two possibilities, right? Either something unusual happened, or the possibility that we rely on in hypothesis testing, our null hypothesis, that initial assumption was incorrect, and perhaps the mean is something closer to what we observed in our sample. So anyways, we have our first example here. I strongly recommend that you pause the video, try this out on your own, see if you can answer this question. But either way, we're here told that USA Today reported 64% of the American workforce felt they were overdue for promotion. In a random sample of 1,500 Americans, 66% said they felt they were overdue for promotion. So this is our sample proportion. It's in the same sentence as my sample size. And then we conducted a one-sided hypothesis test. So is this other P, the report by USA Today, correct? Or do we actually have a value larger than that, which would be indicated by our sample? So this was done, and a p-value was found to be 0.0537. So if we were to draw a picture of what the heck our test would look at, right? The initial assumption was that the real mean is 0.64. The USA Today report was correct. And then what we're interested in as statisticians is, well, if that's the case, how unusual is 66% given that we expected 64%? And this is always that value or anything more extreme. So that's what our p-value is, which we actually know as 0.0537. And now it's just a matter of finding a statement that has this part here about given the null hypothesis is true. And that's what we see in number A, or part A, or answer A. My God. If the population proportion, if P is really 0.64, if we're really centered here, then this is the probability our sample proportion could be greater than that value. That's exactly what this is saying. So that's our correct answer. B just said there's a probability that it really is. This is the most common mistake of how students interpret the p-value, is that they want to say, well, it's our probability for this. So the lower it is, the more likely it is that that's not true. But that's not the case. It is more complicated than that. It's about if this initial assumption is off, what do we have? So those two are out. Neither of them even have the conditional piece we need. And D says if P is really 0.66. So this has the two reversed or backwards. So something to be kind of careful of. It's always about our null hypothesis. If P is really 0.64, the probability we would have gotten our sample.